All right, so looking at the right side of this is where we left off yesterday. Okay, it says to simplify, and then we're going to make sure that we remember to put this in standard form at the end. Number 2 has 2 negatives under the root. So remember, the first thing we want to do is take those negatives out. Okay, so this would be I square root 20 plus 3I square root 45. Then I want to reduce them, so this is 4 and 5, or 2I root 5. This is 9 and 5, which would be, the 3 comes out. 3 times the 3, 9I square root 5. They both have an I, they both have a root 5, which means we can combine them into one, 11I square root 5, or 11 square root 5I. So either of those works as a solution. If this was an open-ended question, we would use the square root SQRT. So 11 times I times the square root of 5, or 11 square root 5I. Okay, obviously I haven't finished your test, but once I do, I'll let you know exactly what those formats would look like. Questions on that one? All right, next one is solving using the quadratic formula. So remember, x equals negative b plus and minus the square root of b squared minus 4ac all over 2a. A is 16, b is negative 4, and c is 3. So I do the opposite of negative 4, which is 4, plus and minus the square root of b squared, 4 squared, minus 4 times a, which is 16, times c, which is 3, all over 2 times a, which is 16. 4 plus and minus 16 minus, this is 64 times 3, 192 over 32. 192 minus 16, negative 176 over 32. I break one, well, first of all, I can pull up I. So it would be 4 plus and minus I, root 176 over 32. And then I break down this at 176. 2 and 88, 2 and 44, 2 and 22, 2 and 11. That's one pair of 2s that's going to the outside, and a second pair. And I end up with 4 plus and minus 4i, the 11's the only thing underneath, square root 11 over 32. Remember, we want to reduce it and split it, because that's probably how the format of the answer is going to be. So 4 over 32 plus and minus 4i root 11 over 32 becomes, this would be 1/8 minus square root 11 over 8i, and 1/8 plus square root 11 over 8i. Again, if you're just doing an open-ended question where you have to submit the picture of your answer, and you wanted to do 1 plus and minus I root 11 over 8, and you want to keep it like that, that's okay. But realize if it's multiple choice or a short answer where it's going to grade it, it's going to be like that second one where it's split up. Questions? We go down 2-4. All right, so again, we're going to do the notes on 2-5 today. We're going to pause tomorrow and try to review like we would if we were taking a quiz. And then Friday, we're going to move into 2-6 so that you can, and Monday, 2-7, Tuesday, Wednesday review, Thursday test. So 2-5 is called the fundamental theorem of algebra. It has a lot to do with what we did in 2-3, where you're given zeros and you have to reduce your function a degree and then find the remaining zeros. It has a lot to do with, if I give you a solution, you giving me the equation, things we've done before. The difference is that now we're going to have i's in there. So that's it. They're adding in the I, or the imaginary number. So linear factorization theorem is, again, a lot of words for something you already know how to do. It says if f of x is a polynomial degree of n, where n is greater than 0, which means the highest exponent is not 0, means there's a variable there, then f of x has precisely r number of roots. So if I had f of x equals x to the 5th followed by blah, 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 there are 5 roots there. It's not to say those roots are not repeated, but there are 5 roots. They are going to be made up of real rational numbers, real irrational numbers, which would be like square root 5, negative square root 5, square root 2, like that, and non-real numbers, which is anything involving an I. So it doesn't mean they are all real numbers, okay? It doesn't mean you're going to list to me 5 answers that don't have I. It means you're going to give me 5 answers. They might repeat, the multiplicity might repeat, but they also might include real numbers. For example, if I just had f of x equals x to the 5th, there are 5 zeros there. So my answer is just x equals 0, but it happens 5 times. Does that make sense? Highest exponent. So it says to be sure you're familiar with various kinds of zeros, the polynomial function. Here's a quick example. So we just went over this. These are the different types you could see. I can see a real whole number like negative 3. I could see a real fraction like 1/2. Those are still both rational zeros. Then I can see something like plus and minus square root 2. Now we get into the irrationals. Then I can see something like 4 minus 5i, 4 plus 5a, and those are now your complex or your imaginary zeros. Remember, complex come in pairs. If 5i is a solution, then so is negative 5i. All right, so this just says find the exact number of roots. You're looking for the highest exponent, which would be 3. That's it. There are 3. Clearly not a test question. Now it says solve. So I want to use what I just learned to figure out how many there should be in my answer, but then I'm actually going to find it. So for A, there should be how many answers? 2. Okay, so I'm going to set this equal to 0, x squared plus 36. Can I factor that? Is that the difference of 2 squares?
Yes.
Oh, thank you. I forgot you were there. No, right? It's actually not the difference of 2 squares. You're close. If it was a minus, yes, but it's not. So I'm going to solve it by subtracting 36. Then square rooting both sides, putting a plus and minus in front of the left. And the square root of negative 36 would be 6i, 1's a plus, 1's a minus. There's my 2 answers, negative 6i and positive 6i. Yep.
Wouldn't 6i automatically be plus or minus? Or no?
What do you mean?
Like, wouldn't it be automatically plus or minus?
Like if you get 6i, you know negative 6i is also an answer?
Yeah.
Yes. But you'll never solve it and just get 6i and have to bring in a negative 6i. It should happen when you solve it. Yeah. All right, B, f of x equals x to the 3rd plus 25x. So what is how many should we have? 3. Okay. I get 0 equals x to the 3rd plus 25x. What's the first thing you can do? Good. Take out an x. And again, the plus is not factorable, so I split these. I get x equals 0 here. I get x squared equals negative 25. X equals plus and minus the square root of negative 25, which is plus and minus 5i. So negative 5i, 0, positive 5i. That's if it said to put it in order from smallest to largest. Obviously, if it just says list it, you can list it any way you want. Still good? Yeah. All right, find all the zeros of the function and write the polynomial as a product of linear factors. Remember, linear factors is your parentheses. So let's start with A. Normally, I factor this. Are there factors of positive 1 to sum to negative 3? No, right? How else could I solve a quadratic? And there's more than one answer here. You could do the quadratic formula. Anything else? Just in case you're super fans of complete the square, you could also complete the square here, right? Obviously, I would recommend quadratic formula. So A is 1, B is negative 3, C is 1. Opposite of negative 3 would be 3 plus and minus the square root of negative 3 squared minus 4 times 1 times 1 all over 2 times 1. 9 minus 4 over 2 square root 5 over 2. Which means my answers are 3 minus square root 5 over 2 and 3 plus square root 5 over 2. Doesn't have to have an I in it, right? Doesn't mean we're having an I every time, but obviously you can also have I's. That's the solution, but then it said write it as a product of linear factors. So I have to do the x minus in front of these. I would do x minus 3 minus square root 5 over 2 and x minus 3 plus root 5 over 2. Two things I got to get rid of, the parentheses and the 2 on the bottom, okay? So I can get rid of this 2 by bringing it out front here. Same thing here, this 2, bring it out front, and I get 2x. Then the negative goes to both, minus 3 plus root 5. 2x. This goes to both, minus 3 minus root 5. So a linear factor does not have a fraction, and you shouldn't have parentheses within your linear factors. You want to distribute that out. There were 2, right? Because we raised this to the second power, there should have been 2 answers. There are 2 answers. Again, these would be my zeros or my roots, and this would be a product of linear factors. If you FOIL those back out, you get your answer, or you get your question, sorry. So obviously if you've got extra time, big if there, but if you have extra time, you can go back.
Wait, how did you put 2? I'm sorry.
You multiply it times the number on the front. Whatever's the bottom just gets multiplied by here. Think about if I have like x minus 1/2, it's the same thing as 2x minus 1.
Oh,
Anything.
No, I just got confused because like under the 3 minus square root 5, I just saw the plus. Yeah, never mind.
Okay,
Yeah.
you're good? Okay. All right, next up is B. F of x equals 16x to the 4th minus 81. So first of all, there should be 4 roots there. 0 equals 16x to the 4th minus 81. Where do I go from here? Can that be factored? Yeah, difference of 2 squares, right? So this would be 4x squared plus 9, 4x squared minus 9. Can that be factored further? The difference of 2 squares on the right. 2x plus 3, 2x minus 3. So this sets equal to 0, this sets equal to 0, and then the one on the left sets equal to 0. Subtract the 9. Divide by 4. Square root, putting the plus and minus in front. The I comes out. The square root of 9 is 3. Square root of 4 is 2. And I get plus and minus 3i over 2. Then I get negative 3 halves here, positive 3 halves here. So my 4 roots, remember there should be 4, negative 3i over 2, positive 3i over 2, negative 3 over 2, and positive 3 over 2. And then I got to write them as a product of linear factors. So x minus goes in front of each of those. X minus minus a negative 3i over 2 becomes x plus 3i over 2. X minus 3i over 2. X plus 3 over 2. X minus 3 over 2. And then get rid of all those over 2's. So the 2 goes to the front of the x. And there's my product of linear factors. So zeros, linear factors. Obviously pay attention to how it asks for it, right? If it just says solve or give the zeros or give the roots, then you're going to list them like on the left. But if it says write them as a product of linear factors, you've got to put them in parentheses following an x. Everybody good? Yeah? Good at home? Questions before we move on? All right. This says find all the possible zeros of the function. So we're going back to the end of 2-3. Then find the actual roots. Write the polynomial as a product of linear factors. Use the factorization to determine the x-intercepts of the graph. And then at the very end, use a graphing utility to verify that the zeros are the only x-intercepts. So let's break it down into its pieces. Start with all the possible zeros. How do I do that? It's only been like 2 days.
The sign changes?
No, that's how many positive and negative. So that's Descartes' rule. That would tell you how many positive and negative there are. How do I find the possibles? The actual numbers that should work.
Last over first.
Good. Plus and minus last over first. So the first thing I got to do is make sure this is in order of decreasing degree. And it is. Factors of the last would be 1 and 16, 2 and 8, 4 and 4. Factors of the first, again, just 1. So this becomes plus and minus 1, 2, 4, 8, 16, all over 1. Which means negative 1, positive 1, negative 2, positive 2, negative 4, positive 4, negative 8, positive 8, negative 16, positive 16. Now we can use Descartes' rule to help us figure out like which ones it would make sense to test. If I count the sign changes here, there's 1 sign change, 2 sign changes, 3 sign changes, 4 sign changes. So there could be 4 or 2 or no positive roots. So it doesn't really help us, except that when I know I get to the end, I should have an even amount of positive roots. But because the possibility is 4, maybe I start with just the positives. If you wanted to change the signs to test the negatives, so let me just show you that process. I probably wouldn't do it just because of time's sake, but if I wanted to, I would plug in a negative x. I get x to the 4th. This would be a negative x to the 3rd times the negative 4, so positive 4x to the 3rd. This goes back positive, positive 8x squared. This goes back positive, positive 16x plus 16. So if we had tested it out using Descartes' rule, what do you notice about the negative roots? Is there any sign changes? Are there any sign changes? No, no sign changes, which means this is how many positives? 0 negative numbers. So I'm going to avoid all the negative numbers in my possible bank. Does that make sense? Yeah? Okay. All right, so let's start with our positive 1. I'm going to write all the coefficients, this time making sure nothing's skipped, right? There's x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and 0, so we're good. 1, negative 1, 8, negative 16, 16. Bring down the 1, 1, 0, 0, 8, 8, negative 8, negative 8. Doesn't work. Go to 2, 1, negative 1, 8, negative 16, 16. 1, 2, 1, 2, 10, 20, 4, 8. Doesn't work. Go to the next positive. 4, 1, negative 1, 8, negative 16, 16. Bring down the 1, 4, 3, 12, 20, 80. Obviously getting too big, right? 4, 64. Too big.
Miss Chris,
Yeah.
isn't it negative 4?
Where?
When you put all the numbers like 1, you put negative 1 right there.
Oh, yes, I did. Thank you.
You're welcome.
I totally did that on purpose so that you can see how easy it is to make a mistake and totally screw yourself over. Don't do that. And that's a lie. I didn't do it on purpose. Okay, so -3, -3, 5, 5, -11, -11 still doesn't work, but 2, 1, -4, 8, -16, 16, 1, 2, -2, -4, 4, 8, -8, -16, and that one does work if you do it right. So now take what I've got left, right? So 2 is one of my roots. I've got x, this would be x to the third, x to the second, x to the first. X to the third minus 2x squared plus 4x minus 8. Let's see if we could factor by grouping. Take out an x squared here, I get x minus 2. Take out a 4 here, and I get x minus 2. I get x minus 2, x squared plus 4. And there are my other roots. Another positive 2. So none of the other roots would have worked. I would have kept going, they wouldn't have worked. But 2 would have worked twice. And then set this equal to 0. I get x squared equals -4, and x equals plus and minus 2i. So I'd get two 2's, -2i and positive 2i. You do not need to list the 2 twice in your root answers, but it does have to be there for your linear factors. So I have to do x minus 2 twice, and then x plus 2i and x minus 2i. Otherwise, when you multiply back out, you're missing numbers. You won't get your original question. So just be really careful. You don't have to list it twice when you give it as an answer, as a root, unless obviously it asks for multiplicity, then it'd be 2. But you do have to include it twice as linear factors. And you cannot do this to replace those 2, because that's not a linear factor. Something squared is not linear. Remember, linear is just to the first power. So don't do this, okay? Your answer should be this. So which of these are going to show up on a graph? Are you going to see the negative and positive 2i on a graph? Nope. Which is why it says determine which ones are x-intercepts. So my x-intercepts should be 2, 0, and that's it. But it should bounce there, right? Because we know that the multiplicity is 2. So now let's go to our, let's see if I have mine pulled up. Nope. Let's go to our graphing utility. X to the fourth minus 4x to the third. I need to move you. There you go. Third. Plus 8x squared minus 16x plus 16. Save it. Graph it. And there we go. Our graph, which is just hitting the x-axis at 2, but it's also bouncing at 2, which confirms that we would have the x-intercept of 2 with a multiplicity of 2 that bounces. Questions?
So we're gonna do some tests?
So you'll have something sort of along these lines where you're going to have to find a root and then reduce it. So you're going to do the same thing like multiple part. Give me the possibles. I might ask you Descartes' rule, like Descartes' rule, possibles, find one, find remaining.
How does the Descartes rule work in here?
You got to count your sign changes from the beginning.
Okay.
So in the beginning there was 4 sign changes, right? And then you reduce it by 2 to find the number of possible positive. That's positives. So you count from the beginning for positives. So it's 4 or 2 or 0. So look, we found 2, right? Then you go to your, because the other ones were imaginary. Then you put in negative x's, simplify it, count again, and that's how many negative roots there were. So there was no sign changes when we plugged in the negative x. We plug in, here, let me group this. Let me zoom back out. We plug in a negative x into all the x's, and then you count again. It's this. We did it. Oh, I lost it. There it is. Group it again. So everywhere there was an x, I put a negative x. Then I simplified it, and then I counted the sign changes again. There were none this time. So Descartes' rule would have told you this part, which is, where are my pencils? There were 4 or 2 or 0 positive real roots. That's what we're counting. And 0 negative roots. Questions on this? All right, so remember we talked about conjugates yesterday. We talked about complex conjugates, right? And we said if I had 2 plus 3i, then my conjugate is 2 minus 3i. Well, conjugates come in pairs when they're complex numbers. If a plus bi is a 0 of the function, then we automatically assume a minus bi is also a 0 of a function. So you know just by looking if it has an I, if it was 7i, then negative 7i is also a 0. If it was 7 plus 3i, then 7 minus 3i is also a 0. You automatically assume it because they have to come in pairs. I'm not going to give you a polynomial that has an I in it in the beginning and ask you to find the roots, which means somehow those i's get canceled, and the way they get canceled is by multiplying by its conjugate. All right, so now we're working backwards. I'm going to give you the root. You're going to give me the actual equation. It says find the polynomial function with a real coefficient that has the given zeros. Real coefficients mean that my answer should not have an I in it, right? Because that would mean it's imaginary. So if A gives you that 3 is a root and 3 plus I is a root, what else do you know?
There's a negative 3 and then
Good.
a minus 5.
So not a negative 3 because that's not a complex, right? That we don't know, but we do know 3 minus I. So it only works for imaginary. So now if I wanted to figure out what this polynomial is, I would do x minus 3 plus I, and x minus 3 minus I. So x minus 3 minus I, x minus 3 plus I. And then I've got to multiply them out. So my recommendation is always start with the conjugates because those are going to cancel out. So start with these. The order doesn't matter when we multiply, so I'm going to pick and choose what I do first. I'm going to start with my conjugates. So carefully multiply these out. X times x is x squared. X times negative 3, negative 3x. X times positive ix. Go to negative 3. Negative 3 times x. Negative 3 times negative 3. Negative 3 times positive I. Then the last one, negative I times x, negative I times negative 3, positive 3i, negative I times positive I, negative I squared. Still has the x minus 3 on the front. Now, if you did that step correctly, your i's should cancel out from the second set of parentheses. So if I go x minus 3, bring down the x squared, I've got a negative 3x and a negative 3x, negative 6x. I've got a positive ix and a negative ix. I've got a negative 3i and a positive 3i. And I've got a minus an I squared, which becomes minus a negative 1, which becomes plus 1 and the 9. With me so far? Now I've got to FOIL out what's left, or multiply out, right? So x goes to all three, x to the third minus 6x squared plus 10x. Then negative 3 goes to all three, negative 3x squared plus 18x minus 30. And then I write it in decreasing degree order. And you'll see it either equal to 0 or you'll see it equal to f of x. Okay, either way is fine. So let me see, I think the homework, let me check it. All right, you do B. So there's a complex root there, which means you've got to add in its conjugate. On web assignment, the homework, it actually gives you the f of x equals, and then you would just write that in as your answer. All right, you should have gotten f of x equals x to the third minus 8x squared plus 14x plus 68. So again, on web assign, it's going to give you the f of x equals, and then you're going to type in the rest. I would probably do the same on your test. So just keep that in mind. Speaking of tests, I'm actually going to divide this test into 2 days. So we just got like sort of an approval that we can start to do that, so that as not to rush that time. Which means we will start the test on Thursday of next week, but then you might do what's coming next, like that 2-6, 2-7, the graphing part, the following Tuesday. So it's not 2 tests. It's just the test divided into 2 testing days. Okay, in between those testing days comes your PSAT. So we'll I'm not going to teach you anything new. We'll just review PSAT stuff, and then you'll continue your test. But just a heads up of what's coming.
Wait, do we PSAT here?
Yeah.
When is it?
God bless you. God bless you. The Tuesday after next. Yeah. So next week's a regular week, and then you have the following Monday is Columbus Day. Wednesday of that week. Sorry. Tuesday would be your second day test with me. Wednesday is the PSAT.
Did we just start that thing where like we had the first and then we knocked off? Because I don't remember that last year.
Yeah, first Friday, third Wednesday are always early release. Yeah. The Archdiocese thing. All right, I think we've got last thing. Yeah, because there's just 2 examples of it. This says find the additional complex 0, FOIL the roots, and then divide the original function by the new quadratic. So this sort of pieces together the last 2 things, okay? I'm going to give you one answer as a root, like one complex answer. You have to assume the second one, right, because you assume the conjugate. You're going to do what we just did, FOIL those out, and get a polynomial from there that you are going to divide into your original function, and it will find you the last roots. Okay, so we're going to walk through this again, kind of baby step our way in. So it looks like this. Use the given 0 to find all the zeros of the function. First of all, by looking at this, you could tell me how many zeros should there be? 3, right? We have 5i. What's the second one? If you have a positive 5i, you have to have a negative 5i. Remember, complex numbers come in pairs. Now, I'm going to take those two and make the polynomial that would be their product. So x minus 5i and x plus 5i. FOIL it, use the shortcut, doesn't matter, right, because they're complex conjugates. If I FOIL it, I get x squared plus 5ix minus 5ix minus 25i squared. X squared, these cancel. This becomes -1 plus 25. So you can use your a squared plus b squared on that because it's a complex conjugate. Now I have to take my original function and decrease it. I'm going to decrease it 2 degrees because it's squared. To do that, I have to divide, and I can't divide synthetically because it's squared. So I have to take this and divide it by that. So on the outside, because it's missing that middle term, is going to go x squared plus 0x plus 25. And on the inside is 2x to the third plus 3x squared plus 50x plus 75. You with me so far? So normally we reduce it a degree using synthetic, but we can't this time because our terms are x squared. So then I would say, okay, what do I have to multiply x squared by to get to 2x to the third? And that would be 2x, multiply it out, 2x to the third plus 0x squared plus 50x. Change your signs. These cancel. 3x squared minus 0x squared would be 3x squared. 50x minus 50x cancels. So I could do 0x because I still need the place value there. And then plus 75. First and first again. So what do I have to multiply x squared to get to 3x squared? Positive 3, right? And I multiply that times all 3 terms. So I get 3x squared plus 0x plus 75. Change your signs. Cancels, cancels, cancels. Remainder 0. If it wasn't, there'd be a problem there, right? Because we said these are zeros, which means the remainder should be 0. And this is my last linear factor. So to find the last 0, I just set that equal to 0 and solve. So my answers are negative 5i, positive 5i, and negative 3 over 2. If it asked for this as a product of linear factors, it would have been x plus 5i, x minus 5i, x plus 3 over 2, which becomes x plus 5i, x minus 5i, oh, I left the I, 2x plus 3. If I FOIL this out, I would get my original question. Questions on that one? Okay, last one, and I'm going to let you try it. So same exact process. The difference this time is my 0 is a complex conjugate, is complex with a real part. The last one didn't have it. So I'm going to do the same exact thing. Use the given 0 to find all the zeros of the function. There's my f of x. And the first 0 is 5 plus 2i. What's the second 0? 5 minus 2i. So put the x minus in front of those, FOIL it out, divide your polynomial at the end. Again, I'll go ahead and let you try it. This is the last one. All right, so when I turn them into linear factors, I get x minus 5 minus 2i, x minus 5 plus 2i. I multiply them out and I get x squared minus 10x plus 29. Again, remember, if there's an I at that point, you did something wrong. You can't have an I at that point. Then, because it's a quadratic, right, and not raised to the first power, I've got to divide using long division. X to the third minus 7x squared minus x plus 87. Nothing missing, so no terms I have to fill in. First to first, I just multiply by x. So x times x squared is x to the third. Negative 10x times x is negative 10x squared. And positive 29x. Change your signs. Cancels. 3x squared minus 30x. Bring down the positive 87. This I'd have to multiply by 3. 3x squared minus 30x plus 20 or 87. Change your signs. Cancels, 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 which it should. Last remaining linear factor would be x plus 3. So when I list all of my zeros, I would get 5 plus 2i, 5 minus 2i, and negative 3. Questions?
What would the linear factors be for that one?
This, just like this. Any other questions on anything we talked about today? So the good thing about today is it forces review on the multiplying, obviously, of the complex numbers. It forces the review on the long division. It forces the review on Descartes' rule, all that stuff, which is what you're going to get tested on. So you just want to make sure you're good on, obviously, everything we talked about today. So your homework is open. It's on WebAssign and Canvas. It is due tomorrow morning. You actually have 14 whole minutes to get a head start or get a brain break, whatever you need. At home, you do need to stay in the Zoom call with me until 9:10 because that's when your bell rings, okay? Obviously, you can use this time to work on your homework, take a brain break, do what you need. This is like that homeroom time. But I'll be here if you have any questions.